Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
All right, let's take a look at homework for 4.14, problems 37 through 41. Examine the XY table at the right. So you got your figure number and the number of tiles. Remember that the figure number really corresponds to the value of X and the number of tiles for Y as far as our rule is concerned. So invent a tile pattern that fits this data. So we want to have figure 0 have 5, and then figure 1, what does this go up to? 9, so it needs to grow up by 4 somehow. So mine, I chose to have 1, 2, creating arms on the top, and 1, 2, creating legs on the bottom. For every single one of these, they increase by 4. And so the growth pattern starts with the original 5. Here's the original 5. And then every time X increases by 1, the number of tiles increases by 4. So by the time you get to, say, the 10th figure, it will have grown by 40 from the original 5, and because 40 times 10 is 4 times 10 is 40, and so it would have a total of 45. And we could go into detail about where those would all be, but let's not get into that kind of detail. We just know that from this growth and this starting point, this is the rule that applies to this situation. Look at the graph to the left. What statement can you make about the tile pattern the graph represents? Well, this tile pattern starts with 7, right? And how much does it go up by? It looks like we're counting by 1s on the X line, and we're counting by 2s on the Y line. So that means that this particular tile pattern increases by 2 every single time. It is showing constant growth. If it were curved, it would be exponential growth or some kind of nonlinear growth. But the ones that have linear growth always are defined by this y equals mx plus b type of a rule, where m is your growth rate, in this case it's 2, and b is how much you start with, which in this case is 7 tiles. So our rule for this situation ends up being y equals 2x plus 7. Each equation below, solve for x and check your solution. All right, so if we take 3x minus 6 plus 1, let's combine like terms and make that 3x minus 5. And on this side, you got your negative 2x minus 5 plus 5x. So when you add the negative 2x and the 5x, you get 3x minus 5. So these are the same expression, which means no matter what number you put in for x here, you would be putting the same number in here, and they're going to be equal to each other. So in this case, it does not matter what value you choose for x, all of them will work. And if you don't believe me, pick 3 different values for x and plug them in, and you'll see that both sides are equal to each other, which proves that all numbers are solutions, or you could also say there are infinite solutions. On this side, we have to do distributive property first before we can combine like terms. So we're going to take the opposite of x and the opposite of negative 1, which is positive 1. We combine the negative 4x's and the negative 1x to make negative 5x's, and the 1 and the 2 make 3. Some of you may have written this as negative 5x plus 3, and that would be okay too. So now, since if I add 5x's to each side, that will mean I'll have a positive number of x's on the left, because negative 2x plus 5x makes 3x. If you had chosen to add 2x's to each side, could have. There's nothing wrong with that. But then you would have taken away 3 from each side, which would have resulted in negative 8 being equal to negative 3x. Same thing. In either case, once you divide each side by negative 3 here, negative divided by negative is going to give you a positive 8/3. Or you just do it this way, and you get x equals 8/3. So generally, when I'm solving these problems, I decide which side of the equation I would get a positive number of x's, and I add balance sets or take away, remove balance sets accordingly. In this case, I think the best thing to do would be add 5x's to each side to cancel out those negative 5x's, and add 5 to each side to cancel out that negative 5, resulting in 3x equals 8. And then you solve from there. And by the way, the check for this one would be horrible. But if you want to guarantee you got the right answer on a test, you pretty much got to do that check. Right, I am thinking of a number. When I double my number and then subtract that number from 5, so we're not taking 2n minus 5, you're supposed to be subtracting this number from 5, so it's got to be 5 minus that. You get negative 1. All right, so by the time you go through and you solve for n, you should be able to plug it in and guarantee that you got the right answer. So I'm going to do what? Oh, you know what I might do here? Let me do it this way. A lot of students don't like having that negative sign there. So if I were to add 2 n's to each side, that would change my equation to 5 is equal to 2n minus 1. And then I can add 1 to each side, and I get 2n equals 6. Now, I'm taking one more step to do it here than I did there. But sometimes people don't like all these negative signs. That confuses them. Here, you still ask the question, what do you multiply times negative 2 to give you negative 6 for an answer? And the answer is 3, right? Just like here, what do you multiply times 2 to give you positive 6? The answer would be 3. So either way, your answer is going to be 3. So let's work through the problem and check it. When I double my number and then subtract that from 5, so I'm going to double my number, which started off with 3, and I get 6. And if I subtract that from 5, do I get negative 1 for an answer? Yes. 5 minus 6 does give you negative 1. So I feel good about my answer. And now for the last problem. Looking at the patterns, playing the silent board game. We're going to look at this right here. We're going to look at this right here. And we only are given 2. Interesting. All right. So if I add 2, there's no way that works here. If I double it, it doesn't work there either. Ooh, goodness gracious. So what if I triple it? I don't think I'm multiplying times a negative because these are both positive numbers. So that means I'm probably going to have to triple this number or quadruple it and then subtract away. So what is 3 times 2? That's 6. And 6 minus 2 would give me 4. So let's multiply this times 3. That's 30, and 3, okay, that's it. So we're going to multiply times 3 and then take away 2. So our rule ends up being y equals 3x minus 2. It would have been nice if they would have given us our 0 value being negative 2. That would have shown us that you had to multiply, then take away 2, and that would have made it a little bit easier, but we kind of figured that out, or at least I did. Hopefully you did too. So once you know the rule, now you can plug in these numbers for either x or y and find all the other. Oh, they told us right there what the rule was. That's cheating. Oh, well, I didn't see it, but now I do, and that verifies that we're correct. So hooray for me, hooray for us. All right, that concludes our homework today. Less than 10 minutes. Good job. All right, let's move on to the next. Bye. Bye.
Hey, feeling good.